Hi friends, hope you are doing well. I am Dr. Ganguly. Welcome to my channel. So today I am going to do a deep dive onto a problem which has been posed by a viewer, and this problem is, why are people not getting job in the typical engineering branches? Why are they only getting job in software, computer science, IT, data science and so on? So essentially we'll frame this problem as software versus engineering, and here I mean the traditional engineering branches, for example mechanical, civil, electrical, chemical, material science, mining and so on. So we are going to discuss 5 different points here, and the 6th point I'm going to make is about why actually computer science or data science may be in trouble down the road. So the first 5 points are about why, at least in the short run, IT is going to boom, and in the long run we cannot be so sure. So let's look at all these points one by one. Now, of course, whenever we are talking about these things, two countries become very important, and these are India and US, because the IT and software sector of these two countries are very closely linked, because a lot of outsourcing takes place to India from US, and also many Indians keep coming to the US on the H-1B visa and other visa types, for example the L1, to work in various companies. So there is a constant back and forth motion here. Labor moves to the US, sometimes people move back, and also a lot of the outsourcing work gets done in India. So we are going to look at all these aspects and see why, as far as India is concerned, it's very hard to get a job in the core engineering disciplines, but also as far as the US is concerned, it's becoming a case where computer science jobs are actually somewhat more problematic in many situations. So let's look at these aspects. So the number one issue has to do with what changed because of remote work. Now, when the pandemic took place, a lot of companies went remote, especially the IT companies, and what happens is that they learned how to do the entire problem completely using different mechanisms such as Zoom, Teams, Skype and so on. So conference calls, meetings which were online were all the norm, and a lot of work got done like that. Now, many of the processes which take place in software companies, they can be completely done in remote. So what happens is, when people were getting job during this time, they were being sent a laptop, they were working from home, and they were giving all the code and different products back to the employer concerned. So the managers learned how to manage this entire process remotely. Now, one of the side effects of this case is that now that the pandemic is gone, many people have realized that if something can be done remote within the US, it can also be done outside the US. So this has led to again an increase in outsourcing as far as IT and software is concerned, and therefore a large number of IT and software jobs are being created in various Indian cities, whether it's Bangalore, Chennai, Hyderabad and so on. So because now you have Zoom, you have time, you have very good bandwidth and so on, you can very easily outsource many things. You can do code reviews on the computer, you can write requirement documents, you can frame a problem very well in terms of software design and send it down to Bangalore, and the problems can be done. So a plethora of new job opportunities in IT, data science and anything to do with computers has been created in India. Now, a negative side effect of course is that the number of jobs created in IT is much larger than in the core engineering discipline. So this has led to some problems here. Now, the number two issue has to do with the size of the economies concerned and the population. So if we look at the US, the size of the complete GDP is about 20 trillion. As far as India is concerned, it is about 4 to 5 trillion. And if you look at the population, the US has about 300 million people and India has 1.5 billion people. So essentially we can say approximately that there are 5 times the number of GDP, or 5 times the amount of GDP as far as the US is concerned relative to India, and India has 5 times the population. So naturally there is a very great likelihood of lot of the software type of jobs getting done in Bangalore and in the different Indian cities. So this problem is going to continue, or this exchange of labor versus capital is going to continue, and so you are going to see a huge number of jobs being created in various Indian cities in the computer science and IT domain. Now this is not just limited to software, it can include any business process, legal outsourcing, human resources, medical processes, and so on. And this is going to continue for a long time. So now let us look at point number 3 as to what is happening in manufacturing. Now manufacturing and what I would say systems engineering is the broad group under which the core engineering disciplines come. So if we look at anything such as a car being made, or you look at an airplane or a power plant or a gas turbine or a steam turbine or roads, all these things are essentially falling under the purview of the classical engineering disciplines such as mechanical, civil, electrical, chemical, and so on. Now here of course there is continuous progress, new factories do come up every now and then, but you can of course see that there is limited growth in terms of the various industries here. So even if various car factories are coming up, the factories are typically going to be involved in manufacturing. So if you are going to raise the production of a car from, let us say, 1 million to 5 million, you are going to need investment in factories, but a lot of these factories use robots all the time. There is a huge amount of automation which takes place, and therefore the jobs which are created are quite less, and most of the jobs are created at the factory level. As far as the design is concerned, the design has already been created. So most of the work here is in terms of design, some of the work is in terms of the various processes which take place, manufacturing, quality, sales, marketing, operations, management, and so on. So one more thing to realize is that most of the large companies which are involved in manufacturing, they are more like system integrators. And so what they do is that they get the various parts of the system built by smaller companies or vendors, and then they integrate everything in the company. So if you look at a typical car company, all the different parts are being made by different vendors. They are often being imported from various countries. For example, the chips may be made in China and so on, and these are then all put together to make the car. So again, the design process of any of these systems is very narrowly focused. It may be taking place only in the country where the company is actually located. So if you are planning to design a car, if you are planning to design a steam turbine, if you are planning to design a wind turbine, the design will actually create very few jobs. So this is one of the problems as far as the traditional engineering fields are concerned, because engineers are often trained to design some kind of product or vehicle or system, and there are only very few jobs out there in terms of design. Now of course there are a lot of jobs out there in terms of selling these things, servicing these things, quality, and so on, but these are like tertiary jobs. They are not really pure jobs in the core discipline itself. So if we take anything, for example, an aircraft, it's very hard to manufacture an aircraft. So you see very few companies which actually do that. For example, there is Airbus, there is Boeing, and there are a few other companies which make smaller jets and propellers, but these designs are made at the headquarters of these companies. So again, that's where the jobs are concentrated here. Now the fourth point has to do with product versus software, and we can see that the number of products which are built are typically very limited. For example, there are many car companies, but we can ask the question, do we really need so many car companies? So what's happening more and more is the better car companies are buying up the smaller car companies, and there are fewer companies all the time. So this is a process of consolidation which takes place in all the traditional industries. So what happens is that the design jobs are getting more and more compressed as far as these companies are concerned. However, if you look at things such as software, you have a huge amount of software coming up all the time. The number of apps in any phone keeps increasing. The number of games which can be produced keeps going up, and so on. So there is a veritable infinite number of possible apps, possible games which are out there which can be made. So essentially what happens is that software is very fertile. There are so many possible softwares you can create to improve the productivity of systems. You see many small companies have come up which help in the office people being more productive, such as products such as Slack and so on. And there are many such products which are being launched. So in any field, whether you want to build a software for tax or you want to build a software for any kind of game, you can always create a software for new games, you can always create an app for something, and so on. So a lot of products are possible in terms of digital media, digital products, and therefore the amount of development which is possible in software far exceeds that in the product domain. So again, that leads to huge amount of jobs in software. Finally, number 5 point has to do with startups. And if you look at any startup, it is much easier to create a startup in the software domain, because all you need is a few computers, a few laptops, and then you can get started on your software journey or on your startup journey. But if you are thinking of creating a startup in a traditional engineering domain, it is certainly going to be very difficult. It is very difficult to now create a new car company, or certainly to create a new company which makes aircrafts or ships for that matters, or even compete with some of the established players in terms of building a new refinery and so on. So this is always going to be very difficult. So again, as far as startups are concerned, most of the startup jobs are also again in the IT and software sector, because you can very easily use Python and any of the new languages which are out there, such as Go, Rust, and so on, to create all kind of software. So you can clearly see that all these point to a huge growth in software data science jobs in the future. Now finally, I'll come to point number 6, which is where the danger lies to these jobs, and that is from AI and ML. Now these themselves have been created by the computer science people, but what is happening slowly is that managers realize that many of the functions which are there, for example, in manipulating data, in handling data and so on, can be done by AI directly. So instead of trying to get all the data manipulated by hand, we can simply ask some kind of AI model as to what should be the end result. So instead of looking at all the data and figuring out who should be given a loan by a certain bank, we can have an AI system which produces all the data and comes up with this judgment by itself that this person should be given a loan. And therefore these kind of challenges are going to be very high, especially the people in the IT field are very vulnerable. I would not say the people who are computer science majors or who know data science very deeply, and certainly people who know AI and ML are going to flourish. But various people who are simply handling tables of data, manipulating them, and trying to extract information from data, they may be impacted by this huge advent of AI and ML. So as far as the US system is concerned, do remember that in US, managers always have this constraint on them that they want to reduce cost, and therefore there are two ways they can reduce cost. They can of course do outsourcing, and the second thing is they can use machine learning and AI. So generally they are trying to do both these things wherever possible. So the impact of this is that a lot of layoffs are taking place in US in the tech sector, and the people who are not in the AI and machine learning domain are being very negatively impacted in this process. So if you are anybody who is in software but who is not in machine learning and AI, the important thing is to get into these areas. But do remember that AI and machine learning are also advancing rapidly, and it is only a matter of time before they are able to do many of the things which are currently being done by data type of people, or those who are manipulating data using pandas, scikit-learn, and so on. So this was my take on software versus core engineering. I hope you enjoyed this video, and if you have any comments, please leave it in the comment section below as to what are your particular thought about it. Maybe you think that people should study pure science more. That's of course a way to go, because fields such as statistics and mathematics are going to be pretty much immune to the onslaught of AI and machine learning. So I'll end my video now, and I will see you in a video sometime soon. See you then.